discuss about MLP for classification task. What is meant by classification? Yes, the target variable is a categorical data, right? So when the target Y is discrete, that is categorical, right? Okay. So for this, I have taken a data set from sklearn, that is breast cancer data set. Most of the times in machine learning, we use this, right? So here I'm going to use loss function. Cross entropy is used, and for evaluation metric, I'm using accuracy, right? Okay, so let us see how to proceed, how to build a model now. From sklearn.datasets, import load underscore breast underscore cancer. So just I have imported the data set, and also I'm importing train test split. So from sklearn.model underscore selection, import train underscore test underscore split. So just I have saved it under the name whole underscore data, which is equal to load underscore breast underscore cancer, right? So let me execute the code now. Yes. Okay. So now x underscore data is equal to whole underscore data dot data, and at the same time I'm writing y underscore data is equal to whole underscore data dot target, right? Now I said about train test split, right? So I'm going to split it now. Train underscore test underscore split x underscore data, y underscore data. The test size I'm taking it as 0.3. Test size I'm taking it as 0.3. Again, here people ask number of questions. What should be the ideal test size? By default, we go ahead with 0.3. In case if you want to go with 0.2 or 0.25 is also fine, right? And then random underscore state is equal to 7. So you can write any number over here, but the point what you have to remember is whatever number you choose over here, that should be maintained till the last of the algorithm, right? So this is basically for the shuffling purpose, right? So the code is written. Let me execute now. Now let me explain about the data set. So the breast cancer data set has total 569 data instances. Out of that, 212 malign and 357 benign. So malign in the sense malignant actually, and 357 is benign instances. And here there are 30 attributes to predict the binary class. Okay, so to identify whether it is M or B, which is like a malignant or benign, right? It sounds interesting, right? So basically we are trying to make a classification model to identify, see, when a data set is given to you, when a test data set is given to you, you have to use it in your model and identify whether the person belong to M category or B category, right? So that is what our goal is. So here, right, the data set is available over here, and as usual we should look into the shape of the data. Since I'm aware of this data set earlier, I have written this, right? But still we cannot go ahead with that. So let me execute this code now. Okay, so let's see now x underscore train, x underscore test, right? So in x underscore train, I have 398 rows and 30 columns. And in x underscore test, I have 171 rows and 30 columns. So if you add it, what we will get? 9, 16, 569 data instances, right? So here we are not talking about these two. And one more thing, you must be very much careful whenever we handle with the classification. We should also check whether it is a balanced data or not. But I don't think it is not much an imbalanced data. So I think we can proceed with this, right? So y underscore train will be 398 and y underscore test will be 171. Yes. So we know we have loaded the data set. Then we have looked into the shape of the data set. What is the next step? Yes, we have to create a model now. So again, I'm going to use sequential model here. So from keras.models, import sequential. So model is equal to sequential. What is the next step? Yes, we have to add layers to that. So Keras layers can be added to the models, right? So sequential in the sense like it will be stacked, right? So that's the meaning of it. And we are talking about the classification problem. So sigmoid layer, or if it is a multi-class problem, we may be going ahead with the softmax, right? Okay, so in case if you want to look into the documentation part, just you can click and have a look at it, right? Fine. So now I'm going to add the layers. Model dot add dense 10. Input shape is 30. Why I am giving 30? Because I know that it has 30 attributes, right? Fine. And then I'm adding an activation here, sigmoid. And then adding hidden layer now. So I'm going to add two hidden layers here. The first hidden layer, I'm taking 10 neurons and the activation as sigmoid. And in the second layer also, I'm taking 10 neurons and I'm using activation sigmoid. And in the output layer, I have written only one, right? So only one. Why it is being written one? Is it right? Here we are talking about the classification problem, right? So here, what is the output going to be, right? So what is the output going to be? So here we have created the layers now. Now let us compile it, right? So we have to compile it now. Once we do this, we have to compile it, right? So what I'm doing now, from Keras, import optimizers. From Keras, import optimizers, and SGD is equal to optimizers dot SGD. I'm using learning rate over here. Learning rate is equal to 0.01, right? And then I'm just compiling it. I'm using the optimizer stochastic gradient descent and loss binary underscore cross entropy, and metrics I'm using accuracy. So let me see the summary of my model now. Okay, so it is saying some error. This model has to build the model first by calling. So I think, okay, so I forgot to run over here. Yes. Okay, so now the model is being built. So now let me fit this with the training data, X train and Y train, and batch size I'm giving it as 50, and epochs is equal to 100, and verbose is equal to 1, right? So let me execute this code now. And now if you look into this loss, what is happening to the loss? Yes, it is decreasing. And at the same time, look into the accuracy. I think it is, yeah, it is increasing, right? So let us evaluate the model now. So loss is 0.6416 and accuracy is 0.6784, right? So now let us print model.metrics underscore names and print the results. So now this is the loss and this is the accuracy of the model, right? So we have got loss and accuracy for the model, right? So hope this is very clear to you how to build a neural network for a classification problem, right?